Now we are taking up the discovery of proton. So after the discovery of electron, proton was discovered, and the one who discovered the proton, the second subatomic particle, the second discovery of the subatomic particle was done by E. Goldstein. E. Goldstein. So he actually had an idea after the discovery of electron that he used the same apparatus actually. So when he just studied the discovery of electron, when he was going through the facts what J.J. Thomson took into consideration, so after performing the same experiment, he get to discover a new particle, that is proton. So how he did, we are taking up this topic, just concentrate on the board. See, he take the same tube, that is the Crookes tube, that is the hard glass tube. You all must be, may remember we done in this thing, we did in the J.J. Thomson. That is, he took a thick glass tube with a vacuum pump, with a gas, with a metal electrodes, with the means of wires, it was connected to the high voltage battery. And same conditions, high voltage battery and the gas at very low pressure was taken. So he said that when the same conditions, high voltage and 10⁻⁴ atmospheric pressure that we did in J.J. Thomson, under same conditions when the cathode rays were emitted, so what happened? When these cathode rays passed through the gas molecule, see I am drawing this gas molecule as this, the small circles representing that they have number of proton equal to number of electrons. They are actually the gas atoms. So when these cathode rays were passing through this gas atom, what happened? They took along the electron present in them with the stream, means electrons present in those gas atoms went with the stream. What happens? So that means the atom become deficient in electrons, so that means which charge exceed? The positive charge. So that means when the cathode rays pass, they take the electron present in the gas atom as along with them, leaving behind the gas molecules as positively charged particle. So that means when negatively charged rays pass through it, they just ionize the gas. That means they take the electron along with them, leaving behind the positively charged particles. These positively charged particles now are, as they are positively charged, I am making few positively charged particles, but keep in mind these positively charged particles will only be formed after the cathode rays pass through them. That means still see, if the cathode rays are passed till this distance, so only these gas molecules are ionized. These gas remain as unionized, because when the cathode rays pass, then only they take up the electrons and make the gas ionized. Okay, so keep coming to again to the point, look at the board, that when the cathode rays pass, they take up the stream of electrons along with them, leaving behind these gas molecules as positively charged ions. Now as we know, the opposite charge attract each other. That means these positively charged particles will get attracted towards the cathode, because cathode is negatively charged and the gas particles are positively charged. So they will get attracted towards the cathode. That means they will form the stream of positively charged particles. So these stream of positively charged particles are further called as canal rays. It will be wrong to call them as anode rays because they are not emitted from anode. Keep in mind, they are emitted just after the ionization of the gas caused by the cathode rays. So when the cathode rays ionize the gas, then only they become positively charged particles, then they start moving towards the cathode due to attraction, and then they form the oppositely charged, then they form the stream of positively charged particles, and these positively charged particles, the stream of positively charged particles is called as canal rays. Canal rays formed of positively charged particle, and that positively charged particle was called as proton. So this is how the E. Goldstein led to the discovery of the other subatomic particle proton. Now the question arises that is the mass of the proton similar to electron? Is the charge you already know it's not similar. Charge, because it forms a positive stream, it is the constituent of positive stream, and cathode electron was the constituent of the negative stream. So obviously proton is going to be positive charge. That means the charge of proton is positive, and as discovered by discovered by J.J. Thomson, that electron is negatively charged. So the proton, definitely the charge of proton is going to be positive now, because it is a constituent of positive stream particle, positive stream rays that was passing. And now coming on to the mass and charge to mass ratio. So the mass and charge to mass ratio was found to be different for different gas taken. As you all remember, I think I told you that in case of cathode rays, the charge to mass ratio and even mass was irrespective of the gas taken and the metal electrodes taken. But in this case, the charge or mass or charge to mass ratio for proton was different for different gases. It is very important. Don't forget it, that the properties of cathode rays are irrespective of the gas and the metal electrodes, but the properties of the anode, that means the mass, charge to mass ratio and the mass, depend upon the gas taken in the discharge tube. So it was found to be different for different gases. So when further experiments were performed, they saw that the E. Goldstein found that it was minimum in case of hydrogen gas. It was minimum for the case of when the hydrogen was taken in the Crookes tube. So the mass or the mass of the hydrogen was considered as the mass of the proton, that is 1.6 into 10 raised to power minus 27 kg, which is almost similar to the mass of the hydrogen atom. As we take it for hydrogen only, so it is similar to the mass of the hydrogen atom. And the charge is of the same magnitude as the electron has, that is 1.6 into 10 raised to power minus 19 coulomb. The difference lies that it was negatively charged and it is positively charged. And the charge to mass ratio was also different, that is 9.5 into 10 raised to power 4 coulomb per grams. So these were the properties of the proton particles, the second subatomic particle, which was discovered by E. Goldstein. I think hope you all have understood that in a proper manner. So I'll just repeat in a short span of time so that you can club all those things. So, the discovery of proton was done by E. Goldstein by the same apparatus under same conditions, that is the high voltage and the low pressure. He said when the cathode rays under these conditions cathode rays are emitted. When cathode rays move, they ionize the gas, making the gas molecules ionized. That means as positively charged particles. Those positively charged particles are attracted towards the cathode and they form the stream of positively charged particles called as canal rays, formed of positively charged particle, that is proton. So the properties of proton exactly same, or you can say opposite where the charge is concerned, that is they also travel in straight line. They can also cast shadow, that means they travel in a straight line. They travel from anode to cathode. And moreover, they do have penetrating effect also. And the charge to mass ratio and their mass was found to be depend on the gas which is taken and the metal electrode that was used. So it was said that for the case of hydrogen it was found to be minimum. So the mass and mass of the hydrogen was found to be the mass of the proton, that is 1.6 into 10 raised to power minus 27 kg, and charge of the same magnitude as the electron has. The difference is only that the nature is positive. And charge to mass ratio, by dividing we get 9.5 into 10 raised to power 4 coulomb per grams. So this is how the proton was discovered. Now we consider the third discovery, that is